Okay, once again, very good morning and thanks for joining. So last 4 session, we discussed about core, not core technical part. We discussed about more on process part. Okay, what are the things we need to little taken care once we got the job. Okay, and what is SSO, what is pager duty, and we discuss about the SWAT calls, much more things. What we need to do. That's what our main focus when we start the journey. Okay, from today from today onwards, we are going to go for core technical part. Okay, the first concept we are going to discuss is how SQL Server. Once again. Okay, yeah. So our main focus is core technical part. So from today onwards, we are discussing complete how SQL Server is working, what are the components, what are the features Microsoft released, and how to use that features, what are the challenges, how to overcome. Let's focus all the stuff from today onwards. But before we go into the core concepts, all the stuff, as a database administrator, every DPA must and should know about how SQL Server engine is working. Means whenever you are going to perform any operation, like see, as we discussed earlier, globally we are going to perform majorly four operations. One is loading the data, one is modifying the data, one is deleting the data, means removing the data, one is reading the data, means we will try to retrieve the data. So entire global, we used to perform four transactions. Means when you try to read the data, how engine is working in the background. When you are loading the data, like it can be insert or update or delete. Okay, how SQL Server is working internally. Not only SQL Server, if you are learning any database management system, this is one of the most thing everyone must know. How to how to install, we'll see in the upcoming classes. But once you install SQL Server, once you connect to the SQL Server, how engine is working means when I'm trying to read the data, when I'm trying to load the data, when I'm trying to load the data, when I'm trying to read the data, how my engine is working, what are the components are there in the engine. So that is the first focus as a database administrator we must also know. For example, this is the tool to connect to the SQL Server. Like every technology, they will provide the tools to connect. Okay, like Oracle, they provided the Toad, SQL Plus, for MySQL Workbench, for Postgres, PC Admin 4. Okay, and for SQL Server Management Studio. These are the common tools we will use to connect to the engines. It can be Oracle or SQL or Postgres or MySQL or MongoDB. To connect to the engines, they provided the tools. So we will download the tool, we will install the tools, and using the tool, you can connect to the engines. We will connect to the engines. So when you are connecting to the engine via SSMS, not only SSMS, either any third-party tools or SQL CMD or SSMS, when you are trying to connect to the SQL Server, okay, our main focus will be the database engine. Our main focus will be the database engine, and we are having rest of the services also, like analysis service, reporting service, integration service. We'll talk this in a separately, not now. Our main focus will be the database engine. Whole this shining will sit under database engine. Our main core component is our database engine. Of course, analysis service is also very important. Reporting service is also very important. Integration service also very important. As a DBA, these services also we will take in care. but we are not a developer where we will design the cubes, where we will design the reports, where we will design the packages. But as a DBA, you need to install these products. You need to grant the permissions. In case if something happened, you need to go and troubleshoot also. So, and you need to migrate also. So these services also DBA need to be taken care. Not in terms of development, but in terms of DBA, definitely these services also we will handle. So we will talk these services later on, not now. Our main focus for whole this training is database engine. So this is our heart. So entire SQL Server, the main heart is database engine. So what is database engine? How database engine is working internally? Everything we'll talk as part of this complete training program. And when you try to connect to the SQL Server, this is how your SQL Server looks like. We'll walk through all the components as well slowly. Now, as part of today, we are going to start the database engine functionality, nothing but database engine architecture. So how SQL Server architecture will work, like how Postgres architecture will works, how Oracle architecture will works, how MongoDB architecture will works, like same how SQL Server architecture will works. So if you start any database management system after SQL, you decide to learn Postgres or MongoDB or Cassandra or Cosmos DB or Sybase or MariaDB, MongoDB, any database management system, the first thing you should learn is architecture. So how the engine is working, either it can be Oracle or MySQL or Postgres or Mongo, how the engine is working means whenever we are going to perform two major operations, one is load the data, one is retrieve the data. One is load the data, one is retrieve the data. When you are loading, how engine is working. When you are reading, how my engine is working. It is a common, sir, again. If you go for any database management system, these are the major two operations will perform. One is loading, one is retrieving. One is loading, one is retrieving. When I load the data, how my engine is working. When I read the data, how my engine is working. If you understand this one, you no need to search in the blogs, prepare massively and explain to the interviewer. Just focus how my engine is working, what are the components are available in the engine. When we go, when we see from SSMS, it is just a component like database engine, and you are going to pass the SQL name and you are trying to connect. That's it. Okay. But internally, there are lots of functionalities are there when you are trying to read the data. For example, I want to read the data. See, it's very easy. Select star from EMP. Select star from EMP. For example, not EMP, sales order. Come on, yeah. Okay. For example, I can, if I wanted to read the data, I can read the data. So we are thinking that, hey, I'm performing a select statement. In Oracle, you will do same. In Postgres, you will do same. In MongoDB, you will do same. Because all the database management system will use a common language called SQL language, SQL language. Like you know about C, C++, Java, Python, R language, right? Like same, SQL is also one language. You will use the SQL as a language and you will try to perform whatever you want. Now, when you are running, it's very easy, very simple. I will run select star from a table and I'm trying to retrieve the data. But what is happening internally? What is happening internally? You should understand the functionality. Internally, how engine is trying to retrieve the data. What checks engine is doing. What are the things engine is doing. If you understand that one, you are good at SQL architecture. Every DBA, before you install, before you access, before you perform, every DBA must and should know about how my engine is working. I hope you got my point, everyone.
Yes.
So this is what first we wanted to learn, how my engine is working, how my SQL Server engine is working, database engine is working. This is our DB engine, right? How my DB engine is working. So that is our main agenda for today's session. So what we are discussing today, SQL Server Architecture means nothing but database engine architecture. SQL Server Architecture or database engine architecture, both are same, sir. Postgres architecture or Postgres database architecture, almost all are same. So when you start anything, first you should understand about the architecture, how that service is working, how my SQL is working internally. So as part of this, so we are going to focus mainly on the database engine as part of today's session. And in the database engine, again, we are having relational engine, storage engine. Under the relational engine, what components are available, storage engine, what components, and we will discuss about the protocols and what services, port numbers. We'll talk more. First, our focus will be the database engine, under the database engine, relational engine, and storage engine. Relational engine and storage engine. First, let's focus on these three components. Later on, we'll go for rest of the components. So as I told you clearly, okay, SQL Server contains many services. Okay, many services like reporting, database engine service, integration service, analysis service, reporting service, and also development tools like SDL. Okay, and management tools like SSMS. Management tool is nothing but SQL Server Management Studio. Just now I opened, right? So this is our SQL Server Management Studio. SQL Server Management Studio is nothing but management tools. Okay, and development tools will falls under SDT, Software Development Kit. Okay, we will discuss that one. And this are all is a separate course, sir. Basically, this all three will falls under MSBI technology. Okay, Microsoft Business Intelligent Technology. What's up? MSBA means Microsoft Business Intelligent Technologies. These three tools will fall under, and this is a separate course. But you are the DBA. Okay, as a DBA, we need to know how to install, how to protect the services, how to protect the data, whatever you are deploying under the services, and how to move this data from one server to another server, and how to grant the permissions, revoke the permissions. As a DBA, you must and should know. And you are not a development. You are not developing any reports, any cubes. Here they will design the cubes. Here they will design the packages. Here they will report the reports. So MSBA team, Microsoft Business Intelligence team, will take care about these activities. But as a DBA, you need to protect the services, everything you need to take care. So you must and should learn everything. You must and should learn everything apart from development. You are not worrying about any development part. You are just focusing on how their functionalities. Is it clear, everyone?
Yes.
Yes, sir.
Yes.
One second. Okay. So we will discuss a separate sessions for analysis service, integration service, reporting service, and data tools. Our main focus will be the engine and SSMS. Will once we complete the core concepts, we will mainly on mostly think we'll discuss on Monday or Saturday. Okay, we'll plan Monday or Saturday. So I think Monday only. Monday we will discuss on installation part, how to install SQL Server using graphical user interface, using command line, We'll talk all the stuff. What are the components required while you are installing SQL Server? We'll spend more time on installation because as a DBA, whatever going forward we are discussing, okay, whether you know, you don't know, no worries. Like you know about always on, you know about log shipping, you know about mirroring, you know about troubleshooting. No one will worry. But as a DBA, firstly you should know how my engine is working. As a DBA, you should know how I need to install the product. As a DBA, you should know how to access that product. This is bare minimum requirements as a DBA. Not only SQL, I mean to say any database management system, how my engines are working, how my DB engines are working, and how to install that engine, how to access that engine. Later on, you can learn what are the best practices, that one, this one, what are the futures, all the stuff. Is it clear, everyone? So first 3 sessions, 3 to 4 sessions, will focus on how my engine is working, how to install my engine, how to access my engine, how my engine is functionally, internally functioning. So this is our main focus. So being I told that we are doing in a different way this training. Okay. First thing, when we go for engine, so technically we are calling it a SQL Server Architecture. Okay, when we especially go for SQL Server Architecture, when you just go to the Google and search for SQL Server Architecture, especially SQL Server Architecture, you will find many images. Almost all are nearby only. All the images will show like a nearby only. But when you go to the Oracle, if you search for, like, if you remove the SQL, if you search for Oracle architecture, okay, uh, you will see a detailed architecture. I love this diagram when we compare with SQL. Being I'm a SQL engineer, okay, but especially when you go for SQL Server diagram, Oracle architecture diagram, I love this one because they mention everything in this diagram. Okay, you will get so whatever they are displaying, 95% SQL is also same. If you are good at SQL, 70 to 75% you are good at Postgres, 70 to 75% you are good at Oracle also. Almost all the engines are same. Where functionality is the same. The functionality, many functionalities are same. Only here and there, the little changes will happen when you go for Postgres or Oracle or SQL. But when you go for SQL, you won't find that kind of uh, architecture. And we think that, okay, oh, see, Oracle architecture is very tough. The people who are starting the journey, oh, Oracle architecture is tough. Oh my God, that many things we need to learn. Oh, SQL architecture is very easy. Okay, nothing. It's a very simple bare minimum diagram is there. Okay, SQL architecture. No, sir. Almost whatever you are doing on SQL, almost Oracle also doing same thing. Almost Postgres also doing same thing. But not sure why Microsoft not designed that much of the diagram. Okay, how the Oracle architecture diagram they released. Not sure why Microsoft is not implemented that much massive detailed diagram. So when you search for SQL Server architecture diagram, you will find this kind of very simplest diagram. Don't think that, okay, oh, SQL is very easy and the diagram is very easy. Okay, I can learn very quickly. Okay, but whatever you are learning on Oracle, same thing you will do. You will learn on SQL also. Almost all are same only. But they not mention that much clearly when you go for Postgres, when you go for SQL, when you go for Mongo, like Oracle architecture. The people who are who are already working as Oracle and they wanted to extend their technical skills in terms of SQL, in terms of Postgres. Okay, ಅದು ಆ ಕಡೆ ನೋಡು. 1 second, sir. Take that water bottle. No, go take it, please. Chalo. Okay. Now, okay. So, especially the people who are Oracle, I just wanted to explain, sir. For the people who are completely SQL, and in future, if you go for Oracle, don't get different thought. Okay, Oracle architecture is very tough. No, you already know about Oracle architecture, sir. If you know about SQL architecture, 70 to 75%, you already know about Oracle architecture. You already know about the Postgres architecture, but only the naming will be changed. So, to explain in a simple way, sir, everyone knows about Amazon, right? Yes or no? Many people knows about Amazon. Throughout the global, we are having Amazon products, Amazon services, sir. And in India, mostly we are having a Flipkart is also one of the most e-commerce company. These are the both leading e-commerce applications. When you go for Amazon, when you go for Flipkart, these two organizations will fight each other in India, especially when you go for India. And both are e-commerce application. So almost both functionality same, right? So Amazon is also selling the products, okay, in terms of groceries, in terms of kitchen, in terms of electronics, in terms of mobiles, in terms of laptops, like similar products you will also see in the Flipkart also. So almost all are similar, but the display part is something different. Means the dashboards are something different. The products are something different. The discounts, the offers will be different, but underlying concept is the same. Both are e-commerce application only. Like assume this is our SQL Server, this is our Oracle. Almost both are same only, but only the front end and the back end little change. But underlying concept is both are engines. Both are engines only. Like same, like Amazon, Flipkart, these are all both are the same e-commerce application, which are where you will find lots of products. Like same, SQL and Oracle is also a database engine. So you won't see much differences when you go for Oracle if you start deeper in SQL. Okay, so that's what we wanted to focus. Now, as part of that, the first thing we are going to learn is our database engine. Okay, you can call it as a database engine, or you can call it as a, don't search with the database architecture, sir. You won't get it. Either SQL Server, okay, database architecture also same thing. So if you search for SQL Server architecture, or if you search for SQL Server database architecture, it's look like same. So our main focus is architecture. Our main focus is a architecture. Now, okay, Subbu, you purchase the SQL Server. Now you will install the SQL Server. You will access the SQL Server. What you will do, you will either load the data or try to read the data. Means whenever, for example, take Amazon. Okay, you wanted to purchase a product. You wanted to purchase a product. Now, what you will do, in India, we are having Amazon, Flipkart. Like when you go for US, other countries, okay, there also Amazon is there, but they're having the other e-commerce applications. So once you open the e-commerce website, it will ask you to log in first. Okay, it will ask you to log in. So when you are trying to create an account, it will ask you your first name, it will ask you your email address. When if you just click on continue, it will ask you your first name, last name, middle name. It will ask your mobile number, your email address, everything it will ask. Once you completely successfully done your sign up, next we will try to connect. Means somewhere your data is loading, right? Your username, your first name, your last name, your username, your email address, your passwords, somewhere it is logging, right? That's logging is nothing but our database engine. Somewhere our data is storing. Somewhere is our data is storing. Now once I logged in, now what you will do? First you wanted to see, you wanted to purchase a mobile. You will go for mobile tab, and you will find lots of products. Now again here we are having lots of filters. Okay, I love iPhones. Someone loves Samsung. Someone loves OnePlus. Okay, what I don't want to see all the products. I wanted to see only the Samsung products. Okay, now I will click on Samsung. I will click on Samsung, and I can also filter. Now my budget is only 25,000 to 35,000. My budget is 25,000 to 35,000. Now say I'm using filters. I'm using filters. When you are reading the sorry, when you are reading you are reading the data before you purchase something. Means before you purchase something, first I wanted to see whether what products are available in the engine, what products are available in the database engine. Okay, what products are available. Now I need to find the products. Later on I will go and purchase it. If I like it, I will definitely purchase it. Otherwise no, I can go for the Flipkart, I can go for some other, because I need to see the product is available or not. I need to see the price. I need to see the discount. So if Amazon is giving 2,000 discount, same product Flipkart is also holding, and Flipkart is offering 5,000 discount. Which e-commerce application you will choose, sir? Flipkart or Amazon? Flipkart, right, everyone? Because it is giving 5,000 discount for us, and both are two leading competitors. Now I will go for the Flipkart. I will do same thing. I will log in into the Flipkart by providing my first name, last name, middle name, username, passwords, along with my email address and mobile number. And I will try to read from here also. And here also I will do the filters. Here also I will do the filters. And I will see what are the discounts are there. So first you are reading the data. You are reading the data. Next, what you will do? Okay, now Samsung S24 FE is a good. My budget is good, and FE is a good in terms of Samsung. Okay, it will give the like a S series only. It is like good product with minimal price. Now I decide to purchase this mobile. Now what you will do? You will try to book the order. You will try to book the order. Means you are loading the data into the database. Now with your login name, whatever login, you are loading the data. While you are purchasing the data, it will ask you your address. Okay, your door number, your street name, your landmark name, your state, country, pin code. It will ask you all the delivery details, and finally you will purchase the product. Means whatever the product you are purchasing, it will load into the database, because you need to track, right? So Amazon need to track how many products are booking in a day, in an hour. Okay, they need to track everything, sir. Who booked this product? They need to deliver, right? They need to deliver. So when you are loading the data, this is loading. You are loading now. When you are booking means you are loading the data. So once your booking is done, your complete product will be loaded into the database again, back to database. Now, once you book the order, once you book the order, your data has been loaded into the engine. Engine is nothing but any one of this database. Okay, which database is holding this information? Any one of the database, you will load your data. You will load your data. Now, after booking, maybe it is displaying when your product will be delivered. When you are booking, it will display when it will deliver. 29th to 30th June it will deliver. it is estimating some delivery date based on your address, whether you are a prime member, non-prime member. It will estimate some delivery date. Now, after 2 days, you wanted to track that information. Again, you are reading the data. Okay, tracking is nothing but again you are reading the data. Means what is the state of my product? Whether the product has been, whether my order has been confirmed. My order need to be confirmed. Later on, my order should be picked. My order should be packed. My order should be shipped. Then only it will deliver, sir. It will deliver. So, for example, first this product it need to deliver from Delhi to Hyderabad. I'm staying in, for example, I am staying a small village. It need to first deliver to the state from the Delhi to Hyderabad. From Hyderabad, it will deliver to my district. From there, someone will deliver to my hometown. So everything I can track the information. Everything I can track means I am reading the data. When you are seeing means you are reading the data. When you are seeing means you are reading the data. Please make a note down. If you're seeing something, you are reading the data. So I wanted to know about my address. Okay, now where name equal to, I will pass here like this. Okay, yeah. Now I wanted to see my address within the database. Now you are reading the data. When you are loading, load the data like insert or update or delete. So globally, these are the more major operations will do, sir. Either insert or update or delete. So what do you mean by insert? First time you are booking, right? It will load the data. It means you are inserting the data. After you you booked, you wanted to update something, it will update. After you booked, you wanted to cancel the product. You are deleting the product, sir. I don't want this product. Let it be, delete my record. I don't want deliver this product. So let it be cancelled. Nothing but deleting the entry or my order entry. So this is what is happening. I hope you understand what engine is doing now. What front end is you are doing. What engine is working back end. High level. This is core high level, sir. I hope everyone clear. No? Yes?
Yes, sir.
Yes, sir.
Now, this is high level. Okay, easy to understand. Easily high level, easy, sir. Okay, I will open the Amazon. I will log it in to the portal. I will book my order. I will track my order. I can cancel my order. I can update my order. It's very easy in the high level. But what is the back end level? Means this is our front end. This is our back end. So we are a back end people. Okay, who is handling the data? Front end is application. It can be any application, sir. Front end is application. Back end we are a DBA people. Now we should understand the back end. Okay, one of the user, and one of the user is trying to book some order and he's trying to perform certain things. So what is happening in the background? What is happening in the background? Now let's talk that, sir, first. So when I go to the SQL Server Architecture, okay, especially SQL Server Architecture, why Subbu you open only this image means basically this contains 3 layers, sir. SQL Server Architecture contains 3 layers. This is first layer. This is our second layer. This is our third layer. Okay, our engine basically contains 3 different layers. One is network layer. Technically, you should call it as a network layer. Okay, one is engine layer, DB engine, One is SQL OS layer, SQL operating system. Like you know about Windows operating system, you know about Linux operating system, like same SQL also contain its own operating system. When you are installing the product internally, SQL is also creating a SQL OS operating system, not operating system, engine, SQL OS capabilities, OS capabilities. So our SQL Server architecture mainly contains three different layers. One is network layer, one is DB engine layer, one is SQL OS layer. As of now, our focus will be these two, sir. In the advanced level, I will talk about SQL OS. Okay, I am not talking anything about SQL OS now. I will talk in advanced level, means advanced performance tuning level, because this is very important. Very important. You should know about many things like memory, IOPS, buffers, schedulers, many more we need to know if you wanted to understand SQL OS. So that's the reason we'll discuss this one in advanced level. Okay. As part of now, we will focus on these two layers. One is network layer, one is DB layer. One is DB engine layer, one is network layer. So our SQL Server internally contains three different layers. One is a network layer, one is a engine layer, one is our SQL OS layer. SQL OS layer. Okay, before I go into the network, first let's talk about the engine. Let's talk about the engine, sir. Is it clear? So SQL, if someone is asking how many layers are contained for SQL Server architecture, means three layers. One is SQL OS, one is DB engine layer, one is a network layer. And each and every layer, we will focus a lot, sir. First, let's focus on the DB engine. First, let's focus on the DB engine. So stop me if you're not understanding, okay? I will repeat n number of times. As a DBA, we mustn't should understand SQL Server architecture, sir. Okay. So especially SQL Server is a Microsoft RDBMS technology, RDBMS tool. Okay, that works on a client and server architecture. There will be client, nothing but Amazon is your client. Okay, Amazon is your client. Amazon is your client. Okay, and server is nothing but our SQL. Client is nothing but it can be Amazon, it can be Flipkart, it can be SQL Server Management Studio. Even SSMS is also client. You should not forget SSMS, sir. SSMS stands for SQL Server Management Studio. SSMS stands for SQL Server Management Studio. So SSMS is also client. Flipkart is also client. Amazon is also client. Anything you are trying to make authentication, like third-party tools, is a client, sir. So SQL Server will follow client and server architecture. There will be client and you will have the server. There will be client and you are having the server. It will follow client and server architecture. Okay. So end users means customers, application team, anyone. Okay. Send a request and SQL Server will accept the request, process the request, share the results with the user. Correct? Yes or no? If you are booking the order, okay, he is going to SQL need to accept that order, SQL need to process the order, and SQL need to update that order. Okay, your order is booked. Even when you are booking the mobiles or everything, it will take some time and it will finally pop up ordered, successfully ordered. Correct? So result, that is the result, sir. So whatever the request you are sending, SQL Server will accept that request. SQL Server will process the request. SQL Server will share the result to the users. This is completely high level. Now let's go into the code technical part, sir. See, when you open SSMS, okay, when you open SSMS, now when you are trying to connect, you are seeing the database engine. Okay, you are seeing the database engine. Oh, when I'm trying to connect, I'm connecting to the database engine. Subbu, everything is handled by the database engine. Absolutely, you are right. Okay, you are right. I'm not saying you are wrong. But internally, our DB engine is divided into two components. Internally, our DB engine is divided into two components. What are the two components? Means one is, okay, one is a relational engine. Okay, technically you can call it as a query processor. Means your query processing. Entire your, so technically you should call it as a queries. Okay, Either you go for Oracle, Postgres, everywhere. Technically, you should call this as a queries. You should call it as a queries. One second. Technically, you should call it as a queries. So, relational engine, okay, process your queries. Majorly, relational engine process query. In the relational engine, there is no data. Data is not available, sir. Only it is processing your queries. Under the database engine, again, SQL Server contains two components. One is the relational engine, one is the storage engine. Even you go for Postgres also same, sir. Okay, Postgres is also same. One, it will process the query. Second, it will have the storage also. So relational engine will process the queries. Storage engine contains the data. Actually, whatever data you want to read, you want to load, everything will be handled in the storage engine. Everything will be handled in the storage engine. The main is also relational engine, sir. Again, relational engine also very important, but the main data is processing in the storage engine. So storage engine holds the data, relational engine holds the queries. So that's the reason we are calling as a relational engine is nothing but query processing engine. Relational engine is nothing but query processing engine. Storage engine is nothing but data processing engine. Is it clear, everyone? No? Yes?
Sir,
Yes, sir.
please again.
Sorry?
Please again. Database
Oh, yeah.
engine
Okay.
content.
See, relational engine is nothing but processing your query, sir. Processing your request. Like either it can be insert or update or delete or select or create or alter, whatever you are doing, right? That queries are processing in the relational engine. Okay. What is
Okay.
processing? So we'll talk. Okay, we'll talk. So storage engine is holding the data. Whatever you either you wanted to read the data, either you wanted to load the data. Entire your data is processing under storage engine. Got it?
Okay. Yeah.
Yep. Okay. So now see, this seems a very simple process from the front end. Yes.
Yeah, I just when the relational engine is processing the query, um, what factors is taken into consideration?
I will talk, sir. I will talk now. Okay, I just explaining high level. Now I need to talk everything this one, right? I will talk, sir, this one.
Okay.
Yeah. See, just first understand high level so that you'll have okay. Database engine contains two engine internally. Okay, one is relational engine which is processing your query. One is the storage engine which is processing the data. If you understand this one, half of the architecture you already know, sir. Half of the architecture you already know. You no need to go and prepare lines of theoretical, pages of theoretical. You no need. Just you should understand. Okay, database engine is our heart for entire SQL Server, which contains two engines. One is a relational engine, one is storage engine. Relational engine is nothing but processing your query, and storage engine is nothing but processing our data. Processing our data. See, this is very simple process from the front end. Front end. See, I told you, right? You will log in into the Amazon portal. You will go to the mobile. You will book the order. It is very easy, right? In the front end. Or take example. You open any bank. For example, ICICI, a bank. You are having your credentials. Now you will connect to the ICICI bank. Okay, with your credentials. With your credentials, you will log into the portal. You will log into the portal. Now you wanted to retrieve the bank statement. Okay, you wanted to see the bank statement. You wanted to see the credit card statement. Okay, in the front end, it is very easy, right? I will go to the statement window. I will go to the statement window and I will choose from what date to so and so date to so and so date, and I will click on submit. and it will read the data in the background, and it will display everything, and it will also prompt you to download the your bank statement in the form of PDF. Okay, it will also prompt you to download, so in the front end it is very easy, but what is happening in the background is very, very important, right? I hope now you understand what I want to convey here. It seems a very simple process from the front end. You are just opening the portal, you are going to the statement, and you are selecting so and so date to so and so date, and you will click on submit, and it is trying to pull the statement. Okay, either 6-month statement or 1-year statement or 2-year statements or 3-year statement. But what is happening in the background? That is very, very important. So, however, there are multiple processes running in the background to fulfill this requirement. So many things are happening in the background to fulfill your requirement. So that process we are learning, sir, now. Okay, Microsoft SQL Server Architecture is a very complex internally mechanism with the 3 major components. I told you, right? One is a network, one is the engine, one is the SQLoids. This is one layer, these two are one layer, and this is one layer. So there are 3 layers. So 1, 2, and 3. Clear, everyone? No confused, right?
Yes, in storage engine, the data will be stored, right?
We'll talk, sir. We'll go. Now we'll go deeper, okay? Now you'll understand. Now.
Hi, Subbu.
Yes.
Please, before we go into for the relational, for the client can be like a car loan application in a bank.
Sorry.
When we talk about in the context of a client,
yeah,
are we talking in relation to a car loan application?
Yeah,
Like
okay.
Like if I want to take a car loan in the bank, is the client related to the car loan application?
Yeah. See,
Are you getting my question?
whatever, sir, either it can be, personal loan or car loan, anything. You need to first fill the form, right? Okay.
Yeah.
You need to first fill the form. What they will do, they will go to your by taking in India, we are having the PAN card. So by using PAN card, they will check the CIBIL score. There is a concept called CIBIL score. Based on the CIBIL score only, your loan will be approved or rejected. Correct? Before they start, they need to see some data. Okay? See, whatever, sir, it's very simple. All are same only. Either you are reading the data or you are loading the data. Only 2 things you are doing. Either load the data or read the data. Correct? Load means either you are freshly inserting or modifying, means updating. I told you, right? When you go to the bank, if you wanted to open an account, you are first inserting the data. Later on, you wanted to update your address, your mobile number, your Gmail. That will go for update. You wanted to remove your account from that bank, you will delete it. Only 3 operations, right, will perform, either entire globally. Throughout the global, will perform 3. Either anything, sir. Either it can be car loan, home loan, house loan, whatever it may be. Either you will insert the data, you will update the data, you will delete the data, or you will read the data. Reading is nothing but electricity bill, water bill, credit card bill, bank statement. This is nothing but reading the data. So whenever you try to pull the bank statement, what and all information you are getting, sir? Your bank logo, bank signature, okay, and address, and your data will be segregated in the monthly basis, okay. Each transaction basis also it is segregating, right? Yes or no? So you are reading the data. How you will get the data? Forget about, no worries. You are reading the data. Either you are inserting or updating or deleting. Globally, you are doing only 4 operations. Of course, create is very important, sir. I need to say, structure is very important. See, without structure, you can't do anything, right? See, without structure, you can't do anything. I am not talking about structures. You already created a structure. Now later on, what we will do, insert, update, delete, select. That is what our main focus are. Either it can be car loan, home loan, house loan, personal loan, whatever it may be. Same thing. You should understand how my data is processing internally. What is happening internally?
Yeah, actually, what I'm asking is that the car loan is also called the client.
See, client is not like a car loan, sir. We can't say like, okay, client is nothing but where you are connecting to the engine. Okay, engine. So you need to make interact with the engine, right? Okay. So application is my, see, this is where I'm trying to, if I'm trying to connect here, okay, if I'm trying to sign in, okay, background, this Amazon is mapped to this client is mapped to the server. Okay. We don't know which server it is mapped. So whenever you click on sign in, and you will provide your email address and password, right? Yes or no? Now
Yes.
in the background, this application will map to the server. How it is mapping? Via network. Via network it is going. Network means not Wi-Fi, sir. Wi-Fi or network. Okay. Network is very important here. So I told you, right? Technically we are calling it a protocol layer. But it is a network layer. This network layer will try to interact. So whatever application it may be, sir, application, don't get confused at all. Don't get confused. Either it can be HTTP level, or it can be application. Means you know about PUBG. Throughout the global knows about PUBG. When you are connecting to the PUBG, also you will provide the username, password, right? It will authenticate, right? You need to authenticate, and it is also storing where you are, how many levels you completed. Somewhere it is storing, right? PUBG also maintaining database. They will also maintain massive database because they need to store your levels. They need to track how many people you killed in the PUBG. Everywhere they are storing somewhere the information. So either it can be app, it can be HTTP, it can be tool. Okay, technically we'll call it as a clients. Agree? Not agree? Everyone, come
Yeah,
on, sir,
agree.
please. Everyone
Yeah,
unmute.
agree.
Okay, you should not. If you're not understanding, that's the biggest problem. I am delivering this time in a different way, sir, to understand easily. Okay, you no need to go and buy hard about. If you search in Google, you will find lots of theoretical part. You don't want by heart all this stuff. If you understand simplest terminologies, okay. Our database engine contains two components. One is relational engine, one is storage engine. What database engine is doing? Database engine is going to take in care complete your process. What process? Whatever user is requesting, until it delivered to the user, your engine is going to take in care. Okay, your engine is going to take in care. Means complete handshake need to be there. What you are requesting, that need to be delivered to the customer. Entire that process is going to taken care by the engine. So you no need to prepare these many pages, all this stuff, blah 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 blah, something very simple. Database engine is nothing but a core component of our SQL Server, which contains internally two engines. One is a relational engine, one is a storage engine. Relational engine is processing the query, storage engine is processing data. In the 2 lines you can answer it, sir, about SQL Server architecture. That's it. Now, definitely they will ask you one question. Hey, can you go into the relational engine components? Now I will explain about relational engine components. If someone is asking, can you brief simply SQL Server architecture? Hey, majorly it contains the database engine, which is the core component of SQL Server, which contains relational engine and storage engine. Relational engine will process the query, storage engine will process the data. I don't know, is there any complexity to explain this stuff in a 2 lines? rather than preparing pages and pages? No, right? No, right, everyone?
Yeah.
Yes.
No.
Yeah.
No. Now I will ask definitely one more question. Hey, can you please brief about what components are available in relational engine? Now I will start explaining those stuff. Now, I hope until this clear, right, everyone? So please watch the session, make a note, sir. You no need to prepare blah, 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 blah. Nothing. Very simple, very simple. Okay, definitions are very easy. You should not by heart the definition, because if you by heart, at one day you may forget. At one day you may forget. I'm promising you. We may forget, not you, sir. We may, sorry. I'm taking back. We may forget. We don't want by heart. We wanted to remember. Remember means we should know the functionality. Now definitely someone may ask you a question called, hey, I understood. Can you please brief about what components are available in the relational engine? You are saying that query is processing, right? How my query is processing? Means now I will tell. In the relational engine, there are three major components. I will talk this one, sir. Hold on. Okay, hold on. In the relational engine, there are three major components. One is command parser, one is query optimizer, one is query executor. Today I am talking query optimizer only for 5 to 10 minutes, sir. In advanced performance tuning, I will talk about 3 to 4 hours. It's not easy to understand, sir. Optimizer. Entire your database engine, optimizer is the heart. Again I'm repeating. Entire your database engine, optimizer is the heart. Without not heart, sir. Sorry, it's a brain. Optimizer is a brain. Okay. If optimizer is not working properly, human being may behave like a differently, like mentally they will behave, right? Like same. If optimizer is not behaving properly, then your performance will impact like anything. In technically speaking, your performance will impact like anything. So don't go deeper, don't understand. Entire this 90 days, you are learning SQL architecture only. Okay, only high level I'm explaining today, and I'm not going for deeper. So now I am briefing about these concepts, but I will talk more about this one in advanced performance tuning. This is the very, very important component. Entire database engine, this will play a major role, sir. First, okay, now let's talk in a technical way. Now first I am trying to provide my email address and my password. I will provide my email address and I will password, and I will click on sign in. Okay, now via network, it is connected to the engine, database engine. From the database engine, it is going to the command parser. First, it will go to the command parser. What command parser is doing? Command parser is the component of relational engine which is checking the syntax checks. Syntax means sometimes you remember whenever you are logged in, invalid email address, invalid password. Anyone face this issue, right? I think everyone face this issue, sir. Don't tell no. Invalid
Yes.
email address, invalid password.
Yes.
So your command parser is checking your syntax. Your command parser is checking your syntax and also semantic. See, three things it is doing. Command parser also plays a major role, sir. Command parser, first it will check the syntax checks. Next, it will check the semantic checks. Next, it will bind the request and prepare the query tree. These are the major three things it will do. What command parser is doing? Command parser first to check the syntax checks. What do you mean by syntax checks, Subbu? I'm not understanding. Okay. I am not understanding means, so whatever the query you are writing, sir. Subbu, I am passing here just my email address and password, right? You are passing your email address and password, but internally it will treat like this, like a query only, sir. Internally, it is treating like a query only. query only, like this query. Okay, where select a star from where email address and the password. Email address and the password. This is your email. Okay, and this is your and password. This is how it is preparing the query internally. Externally, you are just passing your username and password. Externally, you are passing your email address and password, but internally, it is preparing like this query, and it is running the query in the background. In the background, it is running the query. Now, it will check the syntax. There is nothing called parser. See, there is a concept called parser. So, command parser, first, it will check syntax checks. It will check syntax checks. What do you mean by syntax checks, means whatever the query you written, that you written properly or not. So for example, select star from table name. Okay, this is the valid syntax. For example, by mistakenly you written like this. From, in place of from, you written from. Now you are checking the syntax. Now it will throw an error. Incorrect syntax near from. Like same, you are getting invalid email address, invalid password. I hope you are getting my point, everyone. Invalid email address. Now it is checking the syntax. So what is a valid syntax? Here you need to make it as a from. Now if you take the parser, your syntax is perfect. Your syntax is perfect. So technically speaking, it is checking your syntax. First, it will check the syntax. Okay. In the command line also you can do, sir. Okay, not only from graphical user interface by clicking here, set parser only, and whatever the query you are returning, write the query. Whatever the query you are writing, write the query, and parser off, sir. Turn it on, turn it off, turn it on, turn it off, and you can run the query. Now it is checking your syntax is perfect. Your syntax is perfect. So it is not checking whether this table is available, whether this column is available. See, actually this column is not available, sir. In this table, there is no column called test. I can prove you, sir. Okay, if you are performing, tell, understand the concepts and everyone. Okay, definitions. I don't want by heart the definitions. Understand the concept. We will explain like anything. So if I am running the query, see, I am getting these columns, but there is no column called test. There is no column called test here. There is no column called test, but I am passing test as a column. I am reading sales details. Okay, carrier tracking number. Okay, carrier tracking number is there. Sales detail is there. Sales details. Oh, sales details is also not there. Test is also not there. So your command parser is not checking whether this table is available or not, whether this column is available or not. It is not checking anything. It is just checking the syntax. Whatever you are passing at the rate of gmail.com, whatever the password you are passing, this is syntax is perfect or not. Okay, my syntax is perfect. Oh, sorry. My syntax is valid. Okay, my command parser will check the syntax. Hey Subbu, there is no column, right? How, what it is doing? So it is checking only syntax, sir. It is checking only syntax. Once your syntax is passed, now it will do the semantic checks. Your SQL Server, your Postgres, your Oracle, everything, sir. It will do the semantic checks. Every engine is having command parser, sir. Every engine internally it contains the command parser. It will check the syntax checks. It will check the semantic checks. What do you mean by semantic checks, right? Oh, this object is available or not. These columns are available or not. Now it will do the semantic checks. How it will do the semantic checks, Subbu? Okay. There is no graphical user interface to show you the semantic checks, sir. But command line I will show you. Okay, so you need to enable set FMT only on, FMT only. Okay, off. You need to parallelly run this query, sir, at a time, otherwise it will throw an error. And you need to return whatever query you want to do. Check the semantic checks. So when you run this query, it will check this invalid object name. See, it is clearly saying that this object is not available in the database. In this database, this object is not available. Means this table is not available. It is clearly telling. So first it will check the syntax checks. Next it will check the semantic checks. Is it clear, everyone? What command parser is doing, sir? Command parser first it will check the syntax checks. Next it will check the semantic checks. Is it clear?
So the syntaxes is all about how the query is
Written.
rightly written.
That's it, sir. It is not checking whether the table is available, column is available, nothing. It is checking
Okay.
the just syntax. After the syntax, it will go for the semantic checks. Definitely here you will caught. If you are mismatching the table names, mismatching the column names, definitely will caught, sir. I hope you got it. Now, where your invalid email address is getting, sir? In the semantic checks, right? Not in the syntax checks. In the syntax checks, you never face whether you properly enable your email address or not. But in the semantic checks, definitely. And it will throw an error, invalid email address. In the semantic checks, it will check. Got it? No? Yes?
Yes, sir.
Yes.
Okay. Now, after syntax, after semantic, sir, this is high level. This is high level. You can understand, sir. As a DBA, we can understand, but SQL can't understand. This is high level language where SQL can't understand. So, no database engine, no operating system can understand high level language. Whatever you are returning is a high level language, sir. Whatever, either you could take Java, C, C++, or SQL, whatever you are returning is a high level language where human being can understand, but engines can't understand. So what next engine is doing? Engine is converting this high level to low level language. High level to low level language. Getting my point? After first it will do the syntax checks, next it will do the semantic checks, next it will convert if everything success, next it will convert this high level to low level language. High level to low level language where SQL can understand. Where SQL can understand. Again, I'm repeating, internally it is converting from high level to low level where SQL can understand in the form of query tree. Sir, you no need to remember this one. This is, you can directly click here, sir. You no need to remember these points, but only to understand what is happening in the background. I am displaying all this stuff, sir. You won't do this stuff in real world. Again, I'm saying you won't do this stuff in real world. This is for your knowledge purpose, to understand easily how my SQL architecture is working. You won't do this one in real world. Never. Only parser you will do. Rest everything will happening in the background. You won't do all this stuff. You won't get time to do all this stuff. But to understand architecture, you wanted to know this stuff, sir. If you're remembering, well and good. If you're not remembering also, well and good. No worries. But remember the hierarchies, sir. Don't forget the hierarchies, okay? Now, once it complete the syntax, once it complete the semantic, now it is converting your queries into high level to low level by preparing query tree. Query tree. Query tree. Query tree, sir. It is preparing query tree. Okay. To see that query tree for this request, if I wanted to see how the query tree is creating internally SQL Server, now you need to enable the trace file 3604 and you need to enable trace file 8605 if you wanted to see the query tree of the query. Okay, now you need to run at same time all these commands. Okay, you can scroll down. When you execute, okay, you got the data. See, you got the data, and if you go to the messages, you got the query tree. This is entire your query tree, sir. This is entire your query tree. So you will see the table name, you will see any aliases, okay? You will see what table ID, okay? You will see the is there any row, column level, it is user row level, column level, and it will also display about what conversions it happened, everything it will do, sir. You no need to worry about what is happening internally, okay? We won't do all this stuff, but to understand in a technical point of view, your command parser, when I go to the architecture, okay, when we go to the architecture, what command parser is doing, sir? Command parser first checking the syntax, next checking the semantic, and it is binding the query, and it is preparing the query tree. Is it clear? No. Yes. Understandable. Not understand.
When we talk about binding, it's like what?
Binding means it need to see. We don't know what complexity of the query, right? Right, sir. Okay. Binding in the sense you are using here a single table. This is only one table, sir. You also may retrieve one more table, right? Okay. Inner join, sales. Okay. Come on here. Inner join, sales dot sales order details. Okay. Outer join, outer. Okay. Join, and person dot address type. So we don't know uh, how complexity, right? So it need to bind all the tables, all the columns. That is how, sir. Okay, for better understanding. Is it clear? So it is binding the query and preparing the query tree. Okay, preparing the query tree internally. Okay, Subbu, it is preparing the query tree. Somewhere it is storing, Subbu, anywhere it is storing. Yes. Yes. Okay. Whatever the tree it is preparing, it is storing in the memory for a while. It is storing in the memory for a while, sir. Again, I'm repeating, it will store that information in the memory. So there is, don't think about all this stuff, sir. It will confuse you a lot, okay? I'm just displaying, but don't see all this stuff. Select star from this dot dm underscore os underscore memory. Hey, sorry. Dot dm underscore os underscore memory underscore clux. Okay, when you execute, there is a clux called PHDR. Okay, see, cache store PHDR will bound the trees. So whatever the query tree it is preparing, right? That query tree information is storing in the cache for a while. Okay, cache store PHDR will store your query tree information. Somewhere it is tracking, sir. Somewhere it is tracking. Somewhere it is tracking because this query tree only passing to the optimizer. This query tree only passing to the optimizer, sir. To the optimizer. Okay, your query is not processing. Your query is already converted to low-level language in the form of query tree, and that query tree will pass from command parser to optimizer. Is it clear about command parser, sir? Again, don't go memory all the stuff. Don't go memory all the stuff. That is not our agenda today. Our agenda is what command parser is doing. Command parser will check the syntax, will check the semantic, and it will bind, and it will prepare the query tree. That's it, sir. Only 3 things it is doing. Thumbs up, everyone.
Yes, you mentioned that open trace file. What is that, sir?
Trace files, sir. If I want to say something, definitely you need to open the trace files in SQL Server. There are a lot. There are a lot of trace files in SQL Server. Out of that, we are using this trace file for to see certain information.
Okay.
Yeah. like 1322, 1204, 902, 3608, 3604. There are a lot of trace files which we'll discuss. Keep on, we are discussing. Okay, but if I wanted to see something, you need to enable some trace files. Will I do this stuff in real world? No, sir. You never do. But to understand, this is what. Everyone clear about query processor? Sorry. Command parser?
Yes, sir.
A command parser, please, sorry, is it only binding only the from statement, the from, or both the select and the from?
How about?
The command parser, is it
Yeah.
only binding the from statement or
No,
the select
everything, sir.
statement too?
Everything. Whatever
Oh,
you written, it
everything.
is a query. Everything. It can be insert, it can be update, it can be delete, it can be select. Everything need to bind and convert, sir. Low level.
Okay. Convert to a
Everything.
query tree.
Yes, it's a prepare a query tree. Based on this
Okay.
query tree only, your optimizer will start preparing. Okay, we will do what it will do. Optimizer will talk.
Okay. Thank you.
Again, out of these many people, only 2 people are raising voice. Okay, rest I'm not sure why you are so silent, everyone.
Understand, sir.
Okay, for you only, I'm saying in a different way, sir. The people who are starting the journey, you should understand. The people, experienced people, they can understand easily. The people who are starting the journey, easy, sir. You no need to by heart anything. Command parser will check the syntax. I told you, right? Syntax. You don't need to remember all this stuff, sir. Okay, just this is for practicing purpose. I'm displaying. Okay, syntax. There is simple, sir, parser, and it will check the semantic. This is the best example, and it will prepare the query tree. This is the best example. Now, once your query tree is prepared, your query tree information will be stored in the memory. In the memory. In the memory. Please make a note down. In the memory, like a cache. Like a cache. These are all caches. These are all classes, like 342 clerks are there. Each clerk, we don't know, sir. No one knows what all these clerks are doing. No one knows what all these clerks are doing. No one in the global. No one knows what these all clerks are doing. But all clerks are very important. Certain point. Somewhere, some clerks are using, but we don't know what exactly they are using. And we will discuss only top 10 clerks. When we go for advanced performance tuning, we will discuss top 10 clerks only. But we are not discussing all these clerks. Top 10 clerks we'll discuss. We are having almost 342 clerks are there. Will we discuss 342 clerks? No. No one will try, sir. We'll discuss top 10 clerks because those are the consumers. Because those are the memory consumers. Memory consumers. So whatever the query tree it is, 1 second. So whatever the query tree is preparing, the query tree is storing in the memory. Is it clear? Now, sir, questions, yes.
Okay, thank you. Why the boundary, why not query tree when storing the data, when storing the query tree with the bound?
That's what, again, that's what, whatever the this tree is prepared, right? This tree information will be there shortly in the, here, Castor PhD here.
Okay, I was asking like why not query tree but bound tree?
Oh, see, naming is something different. Okay, don't worry. But the
Okay.
query tree will be stored in the cache,
No
sir.
memory.
Okay, yeah.
Because
Now, okay, Subbu, my query tree is prepared. Okay, my query tree is prepared. And command parser is also do one more thing, sir. This is high level. Please try to understand. To simplify, sir, assume you planned one trip. You planned one trip, sir. You with your family, with your friends, with your colleagues, you planned one trip. What you will do, sir, 10 days before, 1 week before, or 1 month before, you will plan everything, right? How many days? How many members? What is the cost? Where I need to go? which place I need to go first, where I need to stay, what places I need to see, how I need to travel to the reach the destinations, how I need to back, everything you will plan, right? Yes, no. Either it can be functions, birthday functions, marriage functions, any receptions, definitely will plan, right?
Yes.
1 month before, 2 months before, 1 week before, 10 days before, you will plan, right? Like same, all the engines will prepare the plan for your query. For your query, whatever query you are running, whatever the request you are doing, for this request, it will prepare the plan. It will prepare the plan. Who is preparing the plan? Optimizer is preparing the plan. Optimizer will prepare the plan, sir. Very, very important. Very, very important. Optimizer will prepare the execution plan. Optimizer will prepare the execution plan. Now, how it is preparing execution plan means, see, in terms of human beings, one is the cost. Cost means money. Money is very important, right, sir? For us, money. Okay, and time. For us, time is very important. Money is also very important. Like SQL also, like engines also, cost in the sense CPU, memory, IO. Cost in the sense CPU, memory, IO. So one is the cost, one is the selectivity. One is the cost, one is the selectivity. How much data you are selecting, how much data you are rendering. So optimizer will prepare the execution plan based on the selectivity, based on the cost. So in specially, I can say optimizer is a cost based and a selectivity based. That's it. That's it, sir. So your optimizer will prepare the execution plan based on the selectivity, based on the cost. As of now, only understand this one, sir. We'll again back to advanced level, right? There we will talk 3 to 4 hours, 5 hours, only this concept. As of now, only understand this one, sir. You don't need to go deeper, okay? Is it clear? What optimizer is doing, sir? Optimizer, whatever the query tree is coming to the optimizer, your optimizer will prepare the plans. Okay, you also will prepare 1 or 2 plans, right? Okay, you also prepare 1 or 2 plans. Finally, you will talk to everyone and you will finalize one plan. Like same, optimizer is also preparing the execution plan, and finally it will choose the best plan. Finally, it will choose the best plan. You no need to say anything to the optimizer, sir. Optimizer is already smarter than us. Optimizer is already smarter than us. So optimizer will choose the best plan. Sometimes optimizer is also worse behaving, sir. I will let you know why it is not behaving worst, why it is behaving worst, what is the challenges. We'll see that one in advanced level. As of now, think that optimizer is a cost base and selectivity base. It will prepare the execution plan. Means whatever the query you are running, it will prepare the execution plan, sir. It will prepare the execution plan for your query. See, it will prepare like this one plan. It will prepare like this plan. I told you, right? Cost base, selectivity base. These are selectivity. 1,21,317 records. It selected, it read from the database. So it will prepare like this one execution plan. Maybe you may see massive execution plan also, sir. In terms of when you go to the massive queries, if we go to the means when you especially working with the when you take the big queries, when you are troubleshooting some big queries, okay? For example, take one query, sir, to present you. No, that's okay. See, it is preparing a massive execution plan. Okay, it is preparing one query cost. It is preparing the T-SQL select statement, assign cost, and it prepared the execution plan, insert operation. It prepared the execution plan for select operation. Means based on your query, based on what query you are running. This is also very small query only. Whatever the complex query in real world, you will see the very complex queries, right? Based on how complex query, optimizer will prepare the execution plans. Optimizer will prepare the execution plan. Don't think too much, sir. Now, just think that optimizer will prepare the execution plan based on the cost, based on the selectivity. Is it clear? Is it clear, everyone?
Yes.
Yes, clear.
Selectivity
Cost.
is not clear for me.
Selectivity is for
cost.
reading the data, how much data you are rendering, how much data you are loading, how much data you are reading. Okay, I will show you practically, sir, what you mean by that selectivity. No worries. Again, sir, no worries.
Okay.
Just remember the terminologies as of now, because I need to go for deeper. You are the
Okay,
people
thank you.
who need to troubleshoot this query. Okay, you are the people who you need to troubleshoot this query. Means if I am running this query, okay, I run this query. Now see, 3 seconds, 4 seconds. Obviously, it will take 10 to 15 seconds, I think so, sir. I'm not sure what indexes I made it here, okay? 15 seconds. This database size is 10 GB, sir. Smaller only. This database size is 50 GB. It took 22 seconds to retrieve 100 records. To retrieve 100 records, it took almost 22 seconds. Now you are the people who need to troubleshoot to reduce this time. For 100 records, why it is taking 22 seconds? I don't want wait for 22 seconds. Sir, customers won't want wait for more time. So time is very precious for them, right? So how you will improve this query performance? So this is what we are going to discuss in advanced level. I hope you understand. So we will
Okay,
read
thank
the
you.
execution plan. See, now you got the complete execution plan. Now you will see the execution plan. Hey, there is a warning operator. There is index scan, index seek, compute scalar, hash match, streaming aggregations, table insert. You will see a table scan. You will see the index scan, blah, 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 something you are seeing. Okay. You are seeing something. Don't get panic, sir. So what your optimizer is doing, optimizer, whatever the query tree it received to the optimizer, it will prepare the execution plan. It will prepare the execution plan. It will prepare the execution plan. This plan will be stored in the plan cache, in the storage engine. This is very important, sir. What query optimizer is doing? Query optimizer will prepare the execution plan based on the cost, based on the selectivity. It will prepare the execution plan and it will store that plan in the plan cache. In the storage engine, it will store in the plan cache. Is it clear high level?
Yes, sir.
Yes, ma'am.
Yes.
Oh, yes. Okay. Now, I need to add one more point for command parser, sir. Okay. Command parser will check the syntax checks, will check the semantic checks, and it will bind and it will prepare the query tree. Once the query tree is prepared, for this query tree, any plan is available, it will verify, sir. If the plan is already existing, it will use the same plan. It won't go to the optimizer and tell to optimizer to prepare one more plan. Okay, your query, your command parser, once it check the syntax checks, check the semantic checks, bind the query and prepare the query tree, it will go to the plan cache, verify any plan is available in the query. Any plan is available. If the plan is there, it will use the same plan. Again, optimizer won't prepare any plan, sir. If there is no plan for that query tree, it will start going to the optimizer. Then optimizer will start preparing the execution plan. Understand, everyone? Again, I'm repeating whole sentence, sir. Okay. Command parser will check the syntax checks, check the semantic checks, bind the request, prepare the query tree, and it will verify whether any plan is available for query tree. Then it will choose the plan. If there is no plan, it will go to the optimizer. Optimizer will prepare the execution plan based on the cost, based on the selectivity. That's it. That's it, sir. In a high level, in a low level, in high level technical terms, that is what you should understand. Okay, not okay?
Okay, sir.
Okay. Now,
Okay.
once the plan is ready, it will move to the optimizer. Now, sorry, it will move to the executor. Now, your query need to execute that plan, whatever the execution plan prepared by the optimizer, whatever the plan is prepared by the optimizer, that plan need to execute, right? Okay, execute by the query executor. In the relational engine, there is no data. In the relational engine, there is no data. Where the data is hosted, sir? Where the data is hosted?
Storage.
The storage engine. So your query executor will send a request to the access method. How, Subbu, all these are happening means, okay, to go deeper, a step head, OLEDB. Okay, there is a concept called OLDB. Okay, there is internally you can search for the tool, sir. OLEDB. You can search in your computer. Okay, so ODBC. You can search in your computer ODBC after you install. Okay, there is a concept called ODBC. Sorry, not OLD, ODBC. Sorry, ODBC. So there is a driver called ODBC drivers. Internally, your ODBC drivers are there, sir. These ODBC drivers are interacting your relational engine and your relational engine and storage engine are communicating with each other using this ODBC connection internally. Internally, using this ODBC, your relational engine, your storage engine are talking to each other. Internally. No one will ask us all these questions again. This is for your knowledge. If you become strong in architecture, SQL is very easy. SQL is very easy, sir. Our concepts are very easy. First 4 to 5 sessions, you will feel very hectic, sir. But I am trying my level best to simplify all the stuff. Okay, to show you little practical, little more practical, less theoretical this time. So internally, your relational engine, your storage engine, mutually understanding via ODBC. Is it clear, everyone? Via ODBC drivers, your relational engine, your storage engine, talking to each other internally, continuously talking to each other. You no need to do anything, sir. You no need to enhance anything. You no need to enhance anything. You no need to do anything. Internally, your relational engine, your storage engine are interacting via ODBC drivers. Okay, not okay, everyone?
Yes, okay.
Drivers are drivers. Like you are having audio drivers, video drivers. Okay, when you install operating system, you are having all these drivers, right? Like same for SQL also, there is a drivers which are talking each other in the background. So your query executor and storage engine are talking to each other. Now what your query executor will do? Hey, it will pass the information to the storage engine. Hey, so and so user, okay, is requesting so and so operation. Will you provide us the data? Okay. Now it will send a request to the access method. Your query executor via ODBC, it will connect to the database engine and sends a request to the access method. Your access method also not holding the data. There is no data in the access method, sir. Okay. Your access method contains APIs. APIs. Application Programming Interface Language. Application Programming Interface Language means whatever the request you are passing, it need to understand. Your storage engine need to understand. Oh, user is requesting for insert. User is performing insert operation. User is performing update operation. User is performing select operation. User is performing delete operation. User is altering the data. User is creating the data. User is dropping the data. User is truncating the data. Means your access method need to understand what request got it from the user. What request got from the user. That need to understand, right? For understand what Microsoft done, Microsoft designed multiple APIs in the background. Multiple APIs, application programming interface languages in the background, where it can understand what you are requesting. Whatever you are requesting, sir, access method can understand what you are requesting. You no need to tell explicitly. It can understand what you are requesting. Now, we are making in a two, sir. One is select, one is no select, sir. No select means either you are reading the data, one is reading the data, one is loading the data. No select in the sense you are not reading the data, you are loading the data. Insert, update, delete, drop, truncate, create, alter. You are loading something, you are modifying something, you are loading something, you are modifying something, you are creating something. So access method can understand whether it is a select statement, whether it is a non-select statement, whether it is a select statement, whether it is a non-select statement with help of this APIs. With help of this APIs, access method can understand it is a select statement or it is a non-select statement. It is a non-select statement. What do you mean by non-select statement? Means insert, sir. Insert means loading the data. Okay, insert. Okay, update, delete. Okay, create, alter. Okay, drop, truncate. These are all non-select statements. Okay, these are all non-select. Select statement is only one, sir. Select. Okay, reading the data. These are all either you are modifying the data, you are updating the data, you are creating the structure, everything you are doing. So access in a simple to understand, access method can understand whether it is a select statement or whether it is a non-select statement. Non-select statement is insert, update, delete, drop, truncate, everything will falls under, sir. We'll talk all this stuff. Okay, no worries. In the upcoming classes. So access method can understand what sort of request you are requesting. Now access based on your request, access method sends a request to the buffer manager. Buffer manager is nothing but your RAM. Okay, your RAM. Buffer manager is a RAM. Okay, buffer manager is nothing but a RAM. In the buffer manager, we are having the buffer pools. In the buffer pools, we are having data cache, plan cache, log cache, okay, log cache, log cache. All these caches are there. In the buffer pool, we are having plan cache, data cache, log cache, multiple caches are there. To understand easily, see sir, when you go to the bank, there will be main locker. And when you go to the accountant where you need to deposit, where you need to withdraw, they will also maintain one small cache, right? Temporary. Once they log into the office, they will go to the main locker, they will get some amount and they will keep in the cache. After ending the shift, they will again take the amount and they will keep in the main locker, right? Yes or no? Take the best example, banking. Come on, sir. Yes, everyone understood? So main
Yes.
locker is your RAM. Main locker is your RAM. In the RAM, you are having caches like a data cache, plan cache, log cache. There are multiple caches are there. Out of this, one of the most culprit is this data cache, sir. This data cache, one of the most culprit, because whatever the data you are, either you are reading the data, either you are writing the data, first it will go to the data cache and verify whether data is available or not. If data is not available, you will create a database, right, sir? It will get the data from here and it will place one copy in the cache, and same data it will send to the user. It will get the data from database, it will place one copy here and sends the data to the user. This is what happening in the background. So once your optimizer prepared the execution plan, your query executor will send a request to the storage engine. Under the storage engine, there is an access method which can understand whether it is a select statement, whether it is a non-select statement based on the APIs. And your access method is also not holding the data. It will go to the buffer manager, nothing but a RAM. And in the buffer manager, we are having buffer pool. And the buffer pool, we are holding the caches. Data cache, plan cache, log cache, all the caches. Our main focus will be the data cache. Entire our troubleshooting will go for data cache only, sir, in terms of memory. So it will verify what user is requesting, whether this data is available in the cache, whether this data is available in the cache, whatever the data you are requesting, right? Whether this data is available in the cache. If not, get the data and place in the cache and sends to the user same data. That is what happening in the background, sir. Is it clear high level, everyone? So what is the database? Okay, we will talk in the next demo, next concept, sir. When we go for storage architecture, we'll concentrate more on this. We'll concentrate, sir, when you go for storage architecture. So I'm not went for storage architecture now. What is the database? What sort of data is there? How data is storing in SQL Server? We'll talk in all the stuff. In the high level, how our engine is processing the request, sir. First, it will go to the command parser, check the syntax, check the semantic, bind the tree, prepare the query tree, go to the optimizer. Optimizer will prepare the plan based on the cost, based on the selectivity, go to the executor. Executor will send request to the access method via ODBC drivers, and access method contains APIs, and easily it can understand whether you are performing select statement, non-select statement, and it will go to the buffer manager, buffer pool. There is a data cache. Whatever the user requested, whether this having data or not, if data is there, it will get the data from here to user only. It won't go to the database. So for example, same query, next time you are executing, it won't go to the database because already data in the cache. So whatever the data is in the cache, it will send the data to the user. Yes.
Why not just directly access the database? Why going out through this process?
Memory is a much faster than disk, sir. Memory you can calculate in terms of nanoseconds. Disk you can calculate in the terms of milliseconds, right? Which is the faster, memory or disk? Memory, right? It's
Memory.
nanoseconds. So that's the reason. See, all the database engines loves memory. Okay, very simple answer, straight away answer. Like take human beings, sir, males and females. Males will love female, right? Like same engine will love memory. That's the simple logic. Don't take serious, sir. Just a joke, okay? Engine will lose memory. That's it. Why Subbu means memory will calculate in the nanoseconds. Memory is much faster than disk, sir. Memory is much faster than disk. Understood, not understood. About database engine processing, sir. Only database engine process we discussed. Apart from nothing else we discussed. No? Yes? Understood? Not understood?
Understood, sir.
Yes, understood.
Very simple, sir. You no need to go for blocks, do all the stuff. Very simple. Okay. Command parser will check the syntax, semantics, bind the request, prepare the query tree, go to the optimizer. So command parser will check whether that query tree contains the any plan cache or plan is there. It will get the plan. Otherwise, it will go to the optimizer. Optimizer will prepare the execution plan based on the selectivity, based on the cost, and go to the executor using that execution plan. In the relational engine, there is no data. So relational engine will send a request to the access method via ODBC drivers, and access method contains APIs to understand what sort of request you are passing, and it will go to the buffer. Under buffer, it contains the caches. It will go to the data cache, whether your data is available or not. If available, get the data to the optimizer. If not, get the data from the database, place one copy in the cache, and sends it to the executor. Then only you will see the data, sir. Until that, you can't see the data. Until that, you can't see the data. See, we are just clicking a submit button when you are pulling the statement. When you are selecting the so-and-so date to so-and-so date, and you are just clicking a submit button. How much process is happening internally? I hope you understand now. How much process it is happening internally. You are just clicking a submit button by choosing start date and date, and click on submit button. You are getting a report for 1 month, 2 months, 3 months, 5 months, 6 months, 1 year, 2 year. But how much process internally is happening? If you clear, then I can go for network layer, sir. Then I will stop today. Okay. Even your plans also storing in the cache, sir. Where is our memory? Yeah. Cache store SQL CP, cache store object CP. These are holding your classes, sir. See, SQL plan, object plans. So these are storing the plan. There are two sorts of requests will perform. One is ad hoc request. One is programmatic request. Okay. Like these are all technically we'll call it as ad hoc request. This technical we'll call it as a ad hoc request. Ad hoc request. What is ad hoc request? What is T-SQL? So you are saying, okay, we'll talk all the stuff in the high level, sir. I don't want confuse you now. Okay, I don't want confuse you now. Again, we're not done about architecture, sir. Again, we'll come back in the throughout overall training. We'll come back again architecture. You will become strong, sir. Now I just pass the high level by focusing on command parser, main focus on command parser. I not focus on the optimizer. I not focus on the plan cache and data cache, sir. Forget about access method, executor, buffers. We are not focusing all this stuff. Our main focus about data cache, plan cache, optimizer, sir. These three we will focus in the advanced level. And you are also see the transaction manager like logmg, lockmg. This also will focus on advanced level only. So much more yet to discuss about architecture. Okay, because you can't understand right away if I'm talking all this stuff. It will confuse us a lot. And finally, you will mess up the entire architecture, sir. So that's the reason I'm just stopping here, architecture. Again, I will come back. But if someone is asking, can you please brief about architecture? Whatever I explain is too good, sir. Take only 1.5 minutes to 2 minutes to explain architecture. Okay, don't explain 5 minutes, 10 minutes, 20 minutes about architecture, sir. Short and sweet architecture is the best, and your interviewer will impress a lot. Someone may ask you, hey, can you please brief about SQL architecture? Okay, so if someone is asking a brief, SQL majorly contains 3 layers, like network layer, nothing but protocol layer, and engine layer, nothing but relational engine and storage engine, and SQL OS layer, SQL operating system layer. Out of that, the main is database engine, Coming to database engine, we are having relational engine, storage engine. Under the relational engine, your query is processing, like command parser, query optimizer, query executor. In the storage engine, we are having access method, buffer manager, buffer pools. Under the buffer pool, we are having data cache, log cache, plan cache. All the caches are there. To brief about components, command parser will check the syntax, will check the semantic, and it will bind the request, prepare the query plan, and check the query plan. And optimizer will prepare the execution plan based on the security, based on the cost, and query executor will send a request to the access method via ODBC. Access method will send a request to the buffer manager, contains the data cache. If data is available, it will get the data to the requester. If there is no data, it will get the data from the database and sends the user. That's it, sir. I know it will hard to explain, okay, but you no need to buy hard all this stuff, sir. If you understand the flow. Is it any confuse everyone? This flow, sir? Is it confusing anyone? Oh, yes.
No.
It's clear, sir.
Clear, everyone? I'm asking to everyone. Only 2 people.
Yes, sir. Clear.
Yeah. Okay, thank you, sir. Now let's focus on network layer, and we'll wind up the session, sir. I told you, right? Whole next 2 sessions also will go little slow only. Okay, from Monday we'll go a little faster, because that we are going to discuss practical, right? You can understand this more on theoretical, sir. That's the reason I will go little slow only. Okay, first 2 to 3 sessions. Now, protocol layer. See, when you are trying to connect to the engine, where our SQL is, sir, under the operating system, right? So on so server only your SQL is installed. Okay, so on so server, you install the SQL servers. So first it need to connect to the operating system, okay, where your SQL is hosted, Okay, first it is connected to the operating system. Either it can be Linux operating system, it can be Windows operating system. Our main focus will be Windows, and I will also train you how to work with the Linux also. Okay, you will also get how to install the SQL on Linux. Okay, we'll train that one as well, sir. Now, once it connect to the operating system, now you are having a network protocols. Okay, you are having network protocols. In SQL Server, you are having 3 network protocols, sir. One is the shared memory, one is the named pipes, one is the TCP/IP. These are the 3 different protocols are there. These are the 3 different protocols. Protocols are there. So, SQL Server will use any one of the protocol to authenticate, to connect to the SQL, So SQL Server network interface is a network protocol layer to connect to the DB engine. Okay, SQL Server supports 3 protocol for the network connectivity. Okay, network connectivity. To understand, see, you are performing insert or update or delete or select or so on so. Okay, now whatever you are doing, that is converting as a packets, as a network packets. Okay, in the form of TDS, tabular data stream. Whatever you are doing, sir, insert or update or delete or sir, SQL can understand you are performing insert, you are performing delete, you are performing update, you are performing something. Network layer can't understand, sir. So what network layer is doing? Network layer is making your connection in the form of TDS packets, tabular data stream packets, network packets. So whatever the connection you are doing, that will make it as a tabular data stream packets to protect your connectivity, in terms of user to transfer the data between database server to client. Means if it need to pass the information to server and it need to pass the information from to application via network, via TDS packets only your data is transferring. Your data is transferring in the form of TDS packets, tabular data stream packets, tabular data stream packets, which is actually designed for Sybase. Okay, this methodology is designed for the Sybase basically in the year 1984 itself. We are using for Sybase. Same thing we are using for SQL Server also, sir. Still we are using TDS packets only for SQL Server. Means when you are trying to authenticate to SQL Server, your data is passing from server to client to server in the form of TDS packets. In the TDS packets, either it is using shared memory or named pipes or TCP/IP protocol. So first you understand this one, sir, everyone. In the form of TDS packets, your data is transferring to the SQL Server, to the client to SQL Server. Is it understand? No? Yes? Everyone?
Yes.
Yes.
Yes. Okay. What do you mean by shared memory? What do you mean by named pipes? What do you mean by TCP/IP support? I need to understand. For example, this is your server. In this server, you install SQL Server. In this server itself, there is a client. In this server, there is a server, SQL Server. This is your client, and this is your SSMS. SSMS is also client. Okay. One tool, sir. Tool is also client. Okay. Tool is also client. So now, when you are trying to connect within the server, you are having tool, you are having tool, you are having SSMS, and server is also in the same server, and you are trying to connect to the server. By default, it uses the shared memory. By default, it will use the shared memory. By default, it will use the shared memory. Means within the same server, if you are opening the client, and same server, if you're having the server, SQL Server, that time SQL Server will use the shared memory to transfer the data, to retrieve the data. It is using shared memory as a protocol. Shared memory is a protocol. Okay, for example, this is one server like a DAL SQL 45 is our SQL Server. There is one more server, DAL App 198 is application server. When you are trying to connect remotely, from other server to SQL Server, it will use the TCP/IP protocol. When you are connecting remotely, either here you are using any third-party tools, SSMS, okay, anything, whatever. If you are connecting SQL Server remotely, by default, it will use the TCP/IP protocol. You need to enable TCP/IP protocol. If you not enable TCP/IP protocol, you can't connect to the SQL Server. So if you are trying to connect SQL Server remotely, you need a TCP/IP protocol. If you're not connecting remotely, shared memory is the good. Means within the server, shared memory is good. Outside the servers, TCP/IP is the good. Are you understand about these two, sir? Everyone?
Yes, sir.
Very simple answer. You don't need to get any confused also. Shared memory is nothing but within the server. If you are connecting SQL Server within the server, by default it will use the shared memory. If you are connecting outside the server, by default it will use the TCP/IP protocol. TCP/IP protocol. Then what do you mean by named pipe, Subbu? Okay, means you know about the LAN cable, right? Don't tell no, sir. Definitely everyone will know about LAN cables. No, LAN cable. LAN cable. No, you know about this LAN cable, right? This LAN cable. So when your client and server are connecting via LAN cable, okay, via LAN cable, then we will use the named pipes. Rare case, sir. We won't even Microsoft suggested disable the named pipes. See, it is in disable mode only. We won't enable named pipes unless there is dependency. Your application, your server is connecting via LAN cables, then only we will use the named pipes. Otherwise, we won't use the named pipes. So widely used protocol is TCP/IP and shared memory. We will disable the named pipes. So when you are authenticating via LAN cables, we use the named pipes, otherwise shared memory and TCP/IP. Microsoft need to disable this also, sir. No need actually named pipes. Now who are using LAN cables, sir? Everyone is smarter. Networks are now smarter. Okay. 10 to 15 years ago, we used to use the named pipes. 1 or 2 times I used the named pipes, sir. Dedicatedly I enable the named pipes for so-and-so client. 7 to 8 years ago. Recently, no. I never get a chance. No one is asking about the named pipes also. And there is one more feature, sir. Nothing but VIA. That is duplicated. Okay, that is duplicated. Microsoft removed that feature. There is one more feature called VIA, Virtual Interface Adapter. VIA stands for Virtual Interface Adapter. Virtual Interface Adapter. If you're connecting, if your server and application is connecting via Wi-Fi, we used to use these protocols. Now, no, sir. Okay. There is no feature called VIA, Virtual Interface Adapter. This is completely duplicated from years ago. 2005 or 2002 itself, this is duplicated. No more VIA concept. So if no one will ask this question, just for knowledge purpose, we are having totally four protocols: shared memory, named pipes, TCP/IP, shared memory within the same server, named pipes, using LAN cable, TCP/IP, remotely, VIA, Wi-Fi connections. Okay, not okay, everyone. That's it, sir, for today. Over to you.
Okay, sir.
Any hard, anyone understood easily? Will I need to change anything?
No, sir. Fine.
Yeah, everyone, the people who are starting the journey, I hope, Hema, you understand. Pratap, you understand. Charan, you understand. I don't know about who are working or not working. Okay, the people who are, I know them. I'm asking. I hope you understand today. No.
Yes, understood.
Yeah. Okay, it's very easy, sir. Not that much. That. Sorry, ma'am.
It takes some days to completely get into our brain.
Oh yeah. You wait for first 10 sessions or dependency sessions, ma'am. Okay. First 10 sessions are dependency session. Definitely on somewhere you are having questions. Wait for 10 sessions. You will become smart in SQL internals. Okay. Yeah. So 10 sessions, I mean to say, are dependency sessions. Because Subbu, you are saying that data is flowing here and there. How, what? Still yet to discuss lots, sir. You need to know about checkpoint, lazy writer, wall writer, log writer, eager writer, ACID properties, database, MDF, LDFs, pages, extents, much more yet to discuss. Okay, then only you will become strong in architectures. So 10 sessions are completely dependency sessions to make you strong in SQL. Okay. So it will be hard, but I'm trying my best to give you simplify. Hope everything will go smoothly only. Stop me if you're not understanding. Stop me if you're not understanding. Okay.
Okay.
Yeah. Thank you. See you tomorrow if no questions. I will summarize this one, sir, and I will share you the material. Okay. No worries. Okay.
Okay.
Yeah.
Thank you.
Yeah. Thank you, sir. See you tomorrow. Yeah, Sandeep. Any questions?
Thank you.
Oh, thank you. Okay. Thank you, sir. Thank you.